Welcome everybody. We are going to talk today about exploring squares using the drawing tools. I am Kathleen Lawler and I'm going to be your host here today. All right, let's look at drawing board geometry. Why do we do this? One, it helps the children apply previously learned arithmetic. So fractions comes alive and we're using our multiplication and we're using our processing, we're looking for patterns. It helps the children learn that math is more than just the computation that arithmetic has. And it also helps us appreciate geometry. It helps us discover the beauty in mathematics, and we're going to see some of those here today. Helps the children attend to precision. And it helps them persevere in problem solving. It helps them prepare for using computer-aided design or CAD software. And most importantly, it helps the children enjoy mathematics. They get to see a different aspect of it that is traditionally taught with just the arithmetic. Just laying some basic groundwork. I believe that everybody here has seen the previous webinars, but let me just touch base real quick. We've got our drawing tools. We've got the drawing board. And then we put the paper on it. Notice that the board is bigger than the paper. We want to have a margin around here. Tape the paper on there, and removable tape works best. You can use the other tape, that's fine, but removable tape is nice because then when you peel the tape off, you can leave your corners on your page intact. Now notice that we're also only taping the top two corners. We're not doing the bottom corners because if we put the tape down here, it will interfere with our work. So just do the top two corners. Here's our T-square. The T-square must hug the edge of the board. Here's our pencil and eraser. Mechanical pencils work best because they will maintain that sharp point that we want for the children or for our work. Drawing. Here's a 45 triangle. Now, you can see we've got the two 45 angles and the 90-degree angle. The triangle must hug the T-square, so this is not going to work. You need to have the T-square hugging the board and the triangle hugging the T-square. If a child is having a tough time working all this out with their hands, you as an adult maybe put a finger on that T-square and make sure that keeps snug up against the board. All right, let's look at squares. We're just going to take a regular square here, and I'm going to fold it on the diagonal. Then take this and compare it to the triangle so the child can see how that 45-degree triangle is related to the squares. They can see the relationship there. All right, let's start by constructing a square. We're going to draw our baseline using our T-square. Move the T-square down and put on our triangle. Now the reason that we move it down is notice how easy it is to see where this starting point is. If I had the T-square up against the line, it's harder to see that. You can't get quite as precise. If you move it down, it's easier to see that's the end of that line or your starting point of your next line. So we're going to draw our sides, flip our triangle over, draw the other side. Then to draw the top, we can draw a diagonal because remember when we folded it, it ran corner to corner. So we can draw the diagonal or we can just draw a tick mark. So the diagonal is the full and the tick mark is just a little mark. So we can see where that top corner is going to be. Excuse me, the top line is going to be. Then I can draw my top line. And we've now drawn a square. Let's take this square and draw it into sixteenths. So the first thing we're going to do, of course, is draw our square, but then we're going to draw our diagonals. Use this up here as our reference. This is what I'm drawing. Draw my horizontal and vertical lines. And then from here, I can start to connect my midpoints. And now I have my square broken into 16ths. Now, let's sit back a second and look at our work. How many squares do you see? How many squares do you see in there? Well, we've got, of course, our big one, and then we've got this smaller one turned 45 degrees. So there's 2. And then look, there's 4 small ones and 4 turned on the point here. So we have a total of 10. Do you see them all there? See them again? We got the big one. We've got the one turned 45 degrees. Then we got the 4 smaller ones and the 4 smaller ones turned on point. There's 10 altogether. We want children and adults to be looking for the patterns in math because there are so many patterns. And once you start to see the patterns, things will fall into place very easily. This helps the children see things in different lights. Let's do 16ths in a different way. Again, look at my upper left. This is where I'm going. We need to start by finding the center. So again, I'm going to use a tick mark. Flip my triangle over, finding the center. And then from here, now I can draw my horizontal and vertical lines down the center. Using the same process, I can find the center of the smaller square and draw my my horizontal and vertical lines. Find the center of this square and the center. We've done this now into 16ths. Now, quick note, when you have, let me go back here, when you have these tick marks, you're going to have these and you are going to erase them, and that is normal. So when you've got the child who's a very precise child or a perfectionist, this is going to make them a little bit crazy, but this is part of the process. We are going to spend some of our time erasing these things, and that is normal. We have squares into 16ths. So we've done it 2 different ways. So often kids think that you can only do something one way. Well, obviously I just did it 2 different ways. Let's look at nested squares. So I'm going to draw my first square. Then I need to draw in order to draw the next one, I have to bisect this line. So I need to find the midpoint. So I'm going to find my center of my square, which we've done before. And from here, then I can draw another tick mark, so we can bisect the line. Now we've got a starting point, and I can draw the sides of that next square. Now, to do the third square in there that looks like this, again, I need to bisect that line. So I can bisect it using a tick mark and draw the next set of lines. And I can keep going until I have them all. And it's fun, actually, for the children to see how small they can get it. Now, here's a very clear case of if you are not precise, this will not turn out clearly. It'll start to get messy and sloppy. So here we are definitely paying attention to precision. Now, let's take this, and what if I just color it? That's kind of pretty. Let's look at the red square. What fraction, the red square is what fraction of the blue square? Well, let me move, and I know you can't do this in real life, but let me move those 3 inside squares. Now it's very easy to see the answer is 1/2. So the red square is half the size of the blue square. Let's look at the yellow square. The yellow square is what fraction of the blue square? Here we'll do it a different way. Let's just visually, first I'll move those, and if I move it up here, I can see my answer is 1/4. But if I go back here, if the red one was half and the yellow one is half of the red, wouldn't my answer again be a fourth? The same thing as we have here. Another way of looking at it is saying the blue area is 3 times greater than the yellow area, which to me doesn't seem right, but it is. When you move it like, you move it like this, well then you can see, of course, it's 3 times the area. Here it doesn't look like it. It's an interesting illusion. Okay, what about the purple square? The purple square is what fraction of the blue square? Oh boy, well, let's figure this out. We know that the blue to the red is half. The red to the yellow is half, so that's a fourth. This would be an eighth and a 16th. So the purple square is a 16th of the blue square. It's very easy to see it if you just pick it up and move it. And you can see that, yes, in fact, 4 would fit across, 4 down, it'd be 1/16. Now, what did we use there? Oh, could that have been our multiplication? Let's look at the right triangle spiral. I'm going to do half of a square, so it's a right triangle, and I'm going to build off of that and spiral my way around. Isn't that pretty? Let's do halves of halves. So I have my square. I have half of it. I'll mark it a half. Let's take that other side and cut that in half, and that would be a fourth. Let's cut that again in half, and that would be a eighth. Again, be a 16th. And we can keep going, a 32nd, a 64th, and it keeps going like this. This is fractions, of course. The Right Start Math program has received awards. The 2014 Practical Homeschooling Reader Award, first place. This was from Mary Pride. And in 2015, we also received the first place award. The drawing board tools, our geometry is taught in levels A through G. The tools are used in C through G. And in level G, every day the children will use their drawing board, T-square, and triangles. Math needs to be taught, so 95% is understood and only 5% memorized. And incorporating the drawing tools and that approach helps build that understanding. Our goal as teachers of mathematics is to help our children transform, expand, and refine these beginning ideas into deeper mathematical thinking. In order to contact us, you can email us at info@rightstartmath.com. And of course, you can also call us. The number can be found on our website or on the back of any of our textbooks.